In this video, we're going to be looking at how to simplify radicals. Now, before we get into that part of it, I wanted to talk about the different parts of a radical. Now, we're used to seeing square root symbols, but that is not necessarily a square root symbol. This is a radical sign. The number underneath is called a radicand, and if there's a number written right here, this is called the index, and it tells us which root we're taking. Now, if we don't see a number, like with the square root, it means that your index is 2, and it's a square root. Like square root of 3, there's not an index written, but technically there is an index of 2. Now, if your radical is a perfect root, there's a pattern into the number of possible roots we can get. So anytime we have an even index, like a square root, a fourth root, a sixth root, if your index is even, there are two possible roots, positive and negative. Now, if you're taking the root, an even root of a positive number, you're going to have two real solutions. So for instance, the fourth root of 16 is plus or minus 2. Those are all the possible roots. Now, if we take an odd root of a positive number, we're only going to have one real root, which will be positive. So for instance, the cube root of positive 8 is positive 2. And that's the only root. But if we take an odd root of a negative number, for instance, the cube root of negative 125, we're going to get a negative answer. In this case, negative 5. Now, if you take an even root of a negative number, you will have two imaginary solutions. So for instance, square root of negative 4 is plus or minus 2i. Now, in this video, we're going to be simplifying radicals, but we're going to be only concerned with the principal root, which is the positive one. And we've done something similar to this, where we simplified square roots. It's the same thing. The difference is the index might be different. It might be something other than a 2. And if that's the case, what's different is going to be when you form your groups. Your index tells you how many have to be in a group in order for you to remove it. So let's take the square root of 17, for instance. If we have the square root of 117, you're going to start by breaking the number down into its primes. Now, 117 is 9 times 13. 9 breaks down into 3 times 3. Now, because this is a square root, your index is 2, it means we have to have 2 in our group to pull it out. We have a pair of 3s, so I can pull out a 3. My leftover 13 stays under the radical. Now, while this technically should be plus or minus, in this section we're only going to be concerned with the principal root. Let's take a look at this one. This one has a coefficient on the outside already. So what we're going to do is we're going to break down the radical, but then whatever number we've pulled out, we're also going to multiply that by 4. So 320, I'm going to break this down. 320 is 5 times 64. Now, I'm going to take a bit of a shortcut here. I can break it down all the way into the prime numbers and multiply those together to get what I'm pulling out. Or I can take the shortcut. 64 is 8 times 8. I got a pair of 8s here. I'm going to pull that out. I have a 5 left over. And this is a lot shorter than continuing and breaking down to 4 times 2 and 2 times 2 and all that. So all I have left to do is multiply 4 times 8 to get 32, square root of 5. Now, those are both square roots, and we've done those before. If it is a cube root, The only real difference is that we have to have three of a kind to group. So let's take this one. 48 is 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. But now my index is 3. So this 3 I'm going to pull down, and when I go to form my groups to take out a coefficient, I need 3 in my group, which I have there. There's a 2 and a 3 left over. So I'm going to pull this 2 out, and my leftovers, 2 times 3, which is 6, stay under the radical. Therefore, my final answer would be 6 cube root of 6. Now, the next one is the cube root of a negative number. Remember, the cube root of a negative number ends up having a negative answer. So when we do this, we have to remember that our answer should be negative. Now, I'm going to start the same way. I'm going to take the 250 and break that down. 250 is 2 times 125, which is 5 times 25, which is 5 times 5. Now again, index is 3, means I have to have 3 of a kind to pull out that as a coefficient. So this 5, I'm going to pull that out, but because this was negative, it needs to be a negative 5. And then cube root of my leftover 2. Now, if you recognize any of your perfect cubes, you could have actually stopped here. Cube root of 125 is 5. So if you know your cube roots, you can take a shortcut there. Alright, a couple more examples, and then we're going to do some with variables. Now, these are both fourth roots, but you do this the same way you did the others. You start by taking your number and breaking it down. So this is 2 and 81. Now, if you know your perfect fourths, you'll recognize that 81 is a perfect fourth, but let's say you don't. 81 is 9 times 9. These are 3 times 3, and I need 4 of a kind to be able to pull it out for a coefficient. And I have that with my 3. So this 3 here times this 3 there, and then 4th root of my leftover 2. Means my simplified answer is 9 4th root of 2. Now let's say you're doing these and you aren't quite sure if you did it correctly. You can always check this out. So let's take this one as an example. Let's say I wanted to check my answer. I have 3, actually let's do it this way. 4th root of 162 times 3. I'm just doing it in slightly different order. Gives me that. And then 4th root of 2 times 9 gives me the same value. So I can test this out by putting in my original and putting in my answer and see if the decimals come out to be the same. Now, if we have a really big number like this, it's a good idea to have an idea of what some of your smaller roots are, so you can avoid having a factor tree that takes up half your page. Like for instance here. If I take this and break it down to simplify it, this is 2 times 1296, but the 4th root of 1296 is 6. So as long as I recognize some of my roots, I can take a shortcut here. This 5 times the 6 when I 4th root that, and then 4th root of my leftover 2 gives me 30 4th root of 2. Now I could have continued breaking this down and then found all my primes, grouped them into groups of 4. I would have still ended up with a 6 out here. This was just a shortcut that I could recognize by knowing some of my smaller roots. Now, let's say you have variables in your radical. What I do is I break them down into two separate roots, square roots, fourth roots, cube roots, whatever it is I'm working with. So let's take this one for example. I'm going to start by simplifying the number just like I would any of the others. It's a square root, so I'm going to need two of a kind. 32 is 2 times 16. 16 is 4 times 4, and I'm taking a shortcut here because I've got a pair of 4s. Now what I'm going to do is I'm going to put this 4 on the outside and then set up two square roots. My leftover 2 I'm putting under the second one. Now what I'm going to do is I'm going to take a look at my variables. Now for us to be able to take the root of a variable, your exponent has to be divisible by the index. In this case my index is 2, so my variable, the exponent, has to be divisible by 2. X is good. X to the fourth is a perfect cube because 4 is divisible by 2. Y to the ninth is not. So what I do is I find the next lowest number that is divisible by 2. In this case, y to the 8th. But I can't change the total number, so I'm going to put y to the first over here. Because remember, when you're multiplying, you add the exponents, and 8 plus 1 gives me the 9. So I still have the same total number of y's being multiplied, but now I've separated it into what I can take the square root of and what I can't take the square root of. So now what I'm going to do is I'm going to take the square root of my variables. So 4 here, square root of x to the fourth is x squared because 4 divided by 2 is 2. For the y, I do 8 divided by 2 to get 4, and then this that I could not take the square root of, I'm just going to bring down. Right. So the next one, fourth root of 112. Start the same way. You take the 112 and you start bringing it down. Now remember, there's certain little tricks you can use to remember if something is divisible by a number or not. For instance, this one's even, so I know it's divisible by 2. It's 2 and 56. This is still divisible by 2. This is 2 and 28. 28, still even, so still divisible by 2. That's 2 and 14, which is 2 and 7. Now that I've broken it down, I'm going to look at my index. I need 4 of a kind. I have that here. So I'm going to pull out a 2, and I'm going to set up 2 fourth roots so I can take care of the rest of it. My leftover 7 is going to go under the second one. Now, r to the 10th. 10 is not divisible by 4. The next smallest number that is, and that should be an r, there we go, is 8. R squared goes over here because 8 plus 2 gives me 10, so I still have the same number being multiplied. For s to the 5th, the next smallest number that is divisible by 4 is 4. My extra s goes over here. Now I'm going to fourth root these to get 2r squared. Remember, you take exponent divided by index. S, technically s to the first power, but you don't have to write an exponent of 1. And then fourth root of my leftovers. Okay. This next one, same idea. We have cube root of negative 81. That's what we're going to simplify first. Now 81, that breaks down into 9 times 9, and these break down into 3's. But my index is 3, so I only need 3 of a kind with an extra 3 left over. Now also, don't forget that because this is negative, I'm actually going to pull out a negative 3 here. And then set up my 2 cube roots. My leftover 3 is going to go under the second one. Now, m squared, 2 is not divisible by 3. And there's no number lower than 2 that is. So I'm not going to be able to take the cube root of any part of this. So I'm going to put all of it under my second radical. Now q to the 16th, 16 is not divisible by 3, but 15 is. So I'm going to put q to the 15th here, and q to the 1st over here. Now I can take the cube root of this. We get negative 3. Q to the 5th, because 15 divided by 3 is 5. And I could not take the cube root of any of this, so I'm just going to bring it down without changing my numbers. Now this next one, we've got the 4th root of a binomial raised to the 8th power. You can treat this, pretend for now that this is just an x. If I had the 4th root of x to the 8th power, I could very easily take the 4th root of that by doing 8 divided by 4 to get 2. That's essentially what you're doing here. You keep that the same. 8 divided by 4 gives me 2. And now here, all that is y plus 3 times y plus 3. So y times y gives me y squared plus 3y plus 3y plus 9, which ultimately gives me y squared plus 6y plus 9. Now most of the time I use the box method. The box method would have worked as well here. I just decided to use FOIL because I haven't used it in a while. Now, just remember that with the variables, they must be divisible by your index. Now, you can probably do it in your head. For instance, let's say I had the square root of 16x to the 5th, y to the 3rd. Okay, I might be able to do that in my head. So square root of 16, that's 4. Now 2 goes evenly into 5 twice with 1 left over. 2 goes evenly into 3 once with 1 left over. So I did that in my head without breaking it up into the 2 separate radicals like I did on these. But if it helps you to see what it is that you're dealing with, I highly recommend that you write them out like this. Alright, that's it for this video. See you next time.